All right, good afternoon. I'm doing this video here to go over the the notes for 1C. I'm going to sort of toggle between here and GeoGebra. So geogebra.org /geometry is this website here. If you'd like to go on it and play around a little bit, you can. I'm just coming on here to do a little demonstration on perpendicular bisectors and angle bisectors. Okay. So I'm going to hit this segment button right here. Okay. And just click, make a segment AB. All right. Now what's cool on this is if we go to more tools, we can find a perpendicular bisector. Okay, so we click perpendicular bisector, and now we want to perpendicularly bisect AB, so I'm going to click A and B. And this line right here is a perpendicular bisector through that. Another thing that's cool is I can move this thing and if I hit the move thing, I move one of these points, I move AB, and that perpendicular bisector moves with it. Okay, so it's still cuts it in half at 90 degrees no matter what. So it's kind of a cool little interactive tool that we can kind of see here. Okay. Now we put a point there, C in the middle. It's our midpoint. Okay. And we know that it's a perpendicular bisector because AC should equal CB. We can do that by going to measure, distance or length, and we'll click A to C and C to B, and we get the same distance. So I'll hit move and move these things out of the way. You don't need to do this, but this is just if you'd like to play around with it, you're more than welcome to. Really cool website. We'll use it more and more as the year goes on. We could also measure the angle. Okay, so if I want to measure the angle right here, what we'll do is, first of all, I'm going to put another point up here, point D. So I'm going to measure the angle A to C to D, and it's 90. Okay, and because this is a perpendicular bisector, as I move this thing, the angle stays 90. All right, and AC and CB keep the same length. All right. So now, again, I just want to make sure that we're clear here that this line right here is the perpendicular bisector. Okay, that line is the perpendicular bisector. D is a point that's on that line. I'm going to make a little segment here. Two segments. I'm going to make a segment from D to A and D to B. I'm going to measure those segments. So come down here to measure distance or length, A, D, D, B. And we notice they should be the same. Your numbers may not be 5, but depending on what your picture looks like, this thing here should equal this thing here. So this equals that. If I were to move point D up and down this line right here, we see that this thing keeps the same distance as this thing. So as this thing gets bigger, this thing gets bigger the same amount, smaller and smaller. Okay, and I can go up or down, doesn't matter. This AD is equal to DB. If we notice this here, we have a triangle, which is going to be an isosceles triangle because we have two equal sides. All right, we don't really need to worry about that right now, but what I'm trying to get to the point of here is that these two sides are equal with this thing being a perpendicular bisector. Okay, which goes to the first part of our notes. If a point is on the perpendicular bisector, it is equidistant, which is the same distance, equidistant from the endpoints of the bisected segment. Okay, so this pink line right here is the perpendicular bisector in our notes. This is the perpendicular bisector. All right, and AC is being bisected. Okay, so what this means is that if we drew a line from D to A and a line segment from D to C, that the length of DA would equal the length of DC. Okay, so you could try these 4 problems out here. It should be pretty simple. Okay, number 2. Let's talk angle bisectors here. So I'm going to go back to GeoGebra, clear my screen. Oh, wrong one. Clearing the ink here. Clear. Don't save. So I'm going to make an angle. So I'm going to hit the segment button here. Click, 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 click. So there we have an angle right here, angle ABC. And I want to bisect it. Okay. Again, we did the construction of it yesterday. What's cool on GeoGebra is you can just hit, there's a tool that does it, angle bisector. So we'll click the angle bisector tool and we'll hit A, B, C. And here we go. We have this angle ABC getting cut in half. We can measure this. Okay, measure angle A, B, C. So angle ABC is 72.1 degrees. I'm going to move it down towards a nice even number here. Okay, and then we'll put a point up here. And then we'll measure each of our little individual angles. So we have measure angle ABD, which is going to be 35.1. And then we can measure angle CBD, 35.1. All right, so these two little angles in here, this angle and this angle are the same, and they add up to this angle. Now I want to talk about the distance from point D to each of these lines right here, okay, to this and this. All right, so what we're going to do is I'm going to draw a perpendicular line through AB to D, and a perpendicular line from BC to D. I'm going to put a point right there and a point right there. So, again, to back up a step, this line here is the bisector. That line there is a bisector, okay? It bisects angle ABC. Okay? Now we have this point here, D, and D goes to E and D goes to F. Okay? If we were to find the distance of DE and DF, this distance or length, E to D, 1.9, D to F, 1.9, and they're the same. So we come move this thing here, ED, DF. All right, now if we move point D up and down the angle bisector, we see ED and DF do the same thing. So ED, DF, 2.4, 2.4, 2.3, 2.3. So the other part of our notes here, if a point is on the angle bisector, then it is equidistant to the sides of the angle, okay? So here's the angle bisector right here, DB. This is the angle bisector. So in this picture, D to J, which is this, is going to equal D to I, which is over there. Okay? And E to G is going to equal E to H. There. Last thing I want to do here is betweenness. All right, you can try these practice problems there once I'm done with the video. If we have a line segment AB and point C is in between. So we have a line segment from A to B. We have point C that's somewhere in between. Okay? Then all we know is that AC plus CB equals AB. Okay? Which means if AC has a length of 2 and CB has a length of 12 or 10, excuse me, then AB has a length of 12. Next, we have an angle ABC. So we have an angle ABC and a ray BD going through it here. Okay, then what we're going to have is angle ABD plus angle CBD is equal to angle ABC. Okay, so ABD is this little purple angle right here, and then plus CBD, this little blue angle right there, equals this whole angle ABC. Okay, so let's say ABD is 30 degrees and CBD is 25 degrees. Then all of angle ABC is going to be 55 degrees. Okay, so from there, try the practice problems out on C, and we'll talk a little bit later in the class. You guys have a good